All right, in 3.2, we are going to continue talking about solving systems of equations. And this is going to continue from yesterday, and it's review from Algebra 1 and Geometry. There really are three ways to solve a system. And remember, a system is two or more. And when we say solve, we want the one point that makes them all true, where they cross. This is what we're after, so you need that in your mind. You're looking for a point. But the three ways are graphing, which we did in 3.1. That is a nice way to get an estimate, but you can't always get an exact answer. Today we're going to talk about substitution and elimination, and these are both algebraic methods where you can get an exact answer, and you have done all three of these before. So substitution is exactly what it sounds like. You're going to replace one expression for a variable so that it's all in terms of x or it's all in terms of y, and you can solve. You have to remember these are always two-step problems. Also, you have to find one of the variables, then go back and find the other, because you're looking for a point. Your answer is always going to be an xy coordinate where they cross. So substitution formally is an algebraic method. Using this method, one question is solved for one variable. So we're going to solve for one variable, then substitute that expression into the other equation and solve. That's your first step. Then you take that answer, substitute it again, and find the missing variable. Now there's always multiple ways to do this, but we always want to pick the easiest, least cumbersome, least amount of work. So when I look at these two equations, I'm always going to look to solve for the variable that doesn't have a coefficient, a number in front of it, if possible, because that means I'm not going to have a division. So I could solve either one of these. So just because I'm going to take this one, I'm going to add 5y to both sides. I'm going to have x is equal to 5y minus 10. Now, these two are exactly the same, just rewritten. Here's the trick. This whole expression right here, 5y minus 10, is exactly the same as x. You have to treat it like a single number with the parentheses. So now I'm going to go back to my original, my other equation, and that's the key. Go to the other one, and wherever there's an x, I'm going to replace it with this, because that is the same as x. And so what I'm going to have is 5y minus 10 plus 4y equals 26. And you can see that this is now in the place of the x. Now I have a single variable y, so I can go about solving for y. Now I left my parentheses in. There's no multiplication out here, so I don't have to worry. I can drop my parentheses. 5y plus 4y is 9y minus 10 is equal to 26. Had there been something out here, I would have had to do the distributive property first, and that's a key place that kids make mistakes. Now I'm going to add 10 to both sides. 9y equals 36, divide by 9, y is 4. So that is my first step. I only have half my answer. Now I need to take this answer and go back to one or the other of my equations and find x. So let's just go to this one, and we're going to say x minus 5 times 4 equals negative 10. Now what I've done is I've replaced, if y and 4 are the same, I've replaced that y with 4. And now I can say that x minus 20 is equal to negative 10. Add 20 to both sides, x equals 10. So my answer is 10, 4. So these two equations are going to intersect at 10, 4. But the cool thing is I can check my answer. Because remember, this 10, 4 is supposed to make both equations true. So I can say, does 10 plus 4 times 4, is that equal to 26? I substituted 10 and 4 into the first equation. So 10 plus 16, yep, that's going to be 26. True. I know my answer works there. I need to check it in the other one. Does 10 minus 5 times 4, does that equal negative 10? 10 minus 20 surely is going to equal negative 10, and that's true. So I know these answers are right before I even leave the problem. Now, elimination is the other method. In elimination, also algebraic, so I'll get an exact answer. You need to eliminate. You need to get one of the variables to drop out. Okay? We're going to do that by adding or subtracting the equations. When we add two true equations, the result is also true. Now, we can't just willy-nilly add or subtract. We might have to do some manipulating to them. So a couple of the things we're going to look for is we are going to look for opposite signs. If two variables, one's plus and one's minus, you definitely want to focus on adding there. So for example, right now, x plus 2y equals 10 and x plus y equals 6. If I just add them together right now, I'm still going to have an x and a y. Remember, the point is to get one variable to drop out because I can't solve things with two variables. So if I don't have opposite signs, how can I change one equation? And that is going to be by multiplying. What can I multiply one equation by so that when I add it to the other, I get those opposites? Positive x, negative x. Positive 2y, negative 2y. So I'm going to pick on the x's. So I'm going to multiply this whole equation by minus 1. And remember to do it both sides. So here's my first one. X plus 2y is equal to 10. After I do this distributive property, that equation is going to become negative x minus y equals negative 6. And then I'm going to add them together. X plus minus x is 0. It drops out. 2y plus negative y is y. 10 plus negative 6 is 4. So there's my first answer. Now we just use substitution to find the other variable. And you can go back to either equation, but I would always go back to your original equation, and I would always show at least your initial step of your work, just so that if there was a need for partial credit, you could have it. I'm going to go back to this one, and I'm going to say x plus 4 equals 6, so I replaced this y with this, subtract 4, x equals 2. So my answer is 2, 4. And I won't go through the checking process, but if I put 2 and 4 into both my equations, or if I graphed them and looked, that is where they would cross. Now, using elimination on this one, this is one where when I look at it first, the first thing I see is that this is a negative and this is a positive. Sweet, I'm going to focus there because if I don't have to multiply by a negative number, I don't want to. It goes better if I don't have to. Now I have to think, well, what numbers do both 3 and 2 go into so that when I add them together, it will become 0. And 3 and 2 both go into 6. So I'm going to multiply this equation by 2, and I'm going to multiply this equation by 3. Now, you're going to multiply the equations by different numbers, which is fine, but both sides of the equation by the same number within that equation. So what are my new expressions? Don't forget your distributive property. So I have 4x plus 6y equals 24. And over here, I have 15x minus 6y equals 33. And then I'm going to add these together. You can see these guys right here are going to become 0. And they're going to become 0 because I built it that way. So this becomes 19x plus 0 is equal to 57. So I divide both sides by 19. So I end up with x is equal to 3. Then I take that 3, remember that was just step 1. I take that 3 and I substitute it into either equation. I'll just take the first one for now. 2 times 3 plus 3y equals 12. 6 plus 3y equals 12. Subtract 6 from both sides. Divide by 3. And so my answer to this is 3, 2. These two lines will cross at 3, 2. Now sometimes some strange things can happen when I do this process. So when I look at these two, negative 3x plus 5y equals 12 and 6x minus 10y equals negative 21, I see a positive 6x and a negative 3x, and I know I can easily transform this first equation by multiplying it by 2. So I have negative 6x plus 10y, don't forget your distributive property, equals 24. This one I don't have to change. 6x minus 10y equals negative 21. Negative 6x plus 6x is 0. 10y plus negative 10y is also 0, is equal to 3. And last time I checked, 0 can never equal 3. This is a false statement, which means that this is an inconsistent system. Inconsistent. It means there's no solution because these are parallel lines. They will never cross. The other weird thing, and this could be 5 equals 7. If you get a false statement, 0 equals 12, 0 equals negative 5, that can never happen, so that means there's no solution. The other thing that can happen is after you do your addition, if you get a true statement, 7 equals 7, something that is always and forever true. This is infinite solutions because you really have the same line. So this one would be consistent and dependent. Okay, so you could come up with a variable equals a number, one solution, a false statement, 0 equals 3, which means you have parallel lines, or you could end up with a true statement, 7 equals 7, 5 equals 5, and that's infinite solutions. It's the exact same line. That is the end of this lesson. Good luck on your homework.